Hi everyone, Dr. Onita Basu here. Today I'm going to go through a flow and velocity calculation for you. So let's get started. So what you're going to do, a flow and velocity calculation. One thing I want you to keep in mind is when we think of flow, which is sometimes also called flow rate, what we're really saying is how much whatever is moving per unit time. And for velocity, what we're really saying is how far. Or, yeah, how far or how fast. How far or how fast. Yeah. So sometimes if you're like, well, I don't like those terms, just sort of think about it as how much, how far, how fast terms instead. Okay, so here's the question. What is the flow or flow rate? And then you're asked to put it in liters per second in a pipe with, that little symbol there means with a diameter equal to 20 centimeters. And then we're also told what the velocity is of the water in the pipe. So if the water is flowing at a velocity of 0.5 meters per second. Okay. And then when you get a pipe calculation, just generally assume that the pipe is full, right? So this is an assumption. Assume pipe is full, unless it says something else. But for most calculations, we would just assume that the whole pipe is filled with water. Okay, so let's break this one down a little bit. Okay, so if we look at the question, there's a couple sections that we can see. One is this one here. It gives us two pieces of information. That's what we're going to be solving for. That's like our main goal is like, what's that flow or flow rate? And it tells us to solve it in liters per seconds, which might mean that we might have to do a units conversion for it. And then we've got different pieces of information. So then we're given that we've got a pipe with a diameter of 20 centimeters, and then we've also got a velocity value here. So this is given, and then this is given. One thing I wanted to comment on is whenever you're solving for something and you get some number that's like in centimeters, always think about converting it into meters. So we're going to convert into meters. And that's because when we do all of our calculations in water and wastewater, they always end up being in like meters, liters, meters cubed, so that centimeters is like not in the final units that we're going to want. So just be like, oh, I think I'm going to have to do a conversion step. Okay, so we're going to solve this one in 2 steps. So let's look at what those steps are. Get my pen handy. So step 1. Okay, the first step is to calculate area of pipe, and we'll do that in meters squared. That's A. And then step 2, calculate flow, and I'm just going to write or flow rate in brackets again. Okay, for F. Okay, so let's start with step 1. So step 1 here, we're going to do the area of the pipe A. So we've got a pipe, so it's going to be cylindrical. So I'm going to do a sketch for you. Right, so we all know what pipes look like, which isn't what this looks like, but just imagine it in your brain a little bit. There we go. And again, I know everyone can always do better drawings than me. That's my pipe. So when we're doing the area, it's like the cross-sectional area through the pipe itself. And the formula is A is equal to pi r squared. And r is equal to the diameter of the pipe divided by 2. And we're given the diameter of 20 centimeters. So this is 20 centimeters divided by 2. So the radius, therefore, is 10 centimeters. And then remember that I had said earlier that whenever you see centimeters, convert it into meters. So convert into meters. So that means that R is equal to 10 centimeters time. So there's 1 meter, and then there's 100 centimeters in every meter. So that R value now becomes 0.1 meters. And the area is pi. So remember, pi is 3.14 times 0.1 meters squared. Never mind that I've got a bit of a funny looking m there, but it's just 0.1 meters and then squared. And when you put that together, you know, sometimes some people don't like to use the square function on their calculator. So square just means it's multiplied twice. So you can also just do it this way. And then when you put those on your calculator, you're going to get 0.0314 meters squared for the area. And now we're going to do step 2. Okay. So for step 2, where we're calculating, just clear my throat for a second there. Step 2 is the flow in liters per second, and that is equal to area, which we just calculated, times velocity, which we were given. So F is equal to our area value, 0.0314 meters squared times 0.5 meters per second. And that would give us 0.016 meters cubed per second. Okay? But remember what the question said. It wants to be frustrating and have you convert it into liters per second. So we're almost done. We just have to do one last conversion step. So if we take this value of 0.016 meters cubed per second, and then we multiply it out by our little conversion or correction factor. So for every meter cubed, there is 1,000 liters per meter cubed. And so that becomes 16 liters per second. Okay. So that means that through that pipe, the water is flowing at 16 liters per second. And that's our flow and velocity calculation. Thanks.